Hi. In this video, we're going to look at another example of solving problems using impulse and the change in momentum. So let's get started. A lacrosse player named Mandy slings a 0.35 kilogram ball across the field at a speed of 14.7 meters per second towards her teammate Leah. Leah holds out her stick to catch the ball, bringing it to rest in 0.33 seconds. So I'm going to draw a quick picture again. It's always helpful to visualize this situation. So I would encourage you, if you're working this out alongside me, as you know, would be helpful probably. I would encourage you to also draw a picture. So we have the ball moving to the right. I'm going to say I get to choose the direction. It didn't say which way. To the right at 14.7 meters per second, and then after the ball is brought to rest in the lacrosse stick. So there's my best lacrosse stick. Okay. Determine the impulse delivered to the ball by Leah. So to find the impulse, right, there's two different ways that you can typically go about finding impulse. We know that impulse is equal to the force times the time. I'm looking at the problem up here. I don't see a force anywhere. I see a time, but I don't see a force. So the other option would be to use the relationship between impulse and momentum. Impulse is equal to the change in momentum. And just to be really clear, the change in momentum is the final momentum minus the initial momentum. So it looks like we are able to find the momentum of the ball because we're given a mass and a velocity. And so we can figure out pretty easily what the momentum of the ball is. We know it comes to rest, so we know it ends at 0 momentum. So let's just go ahead and work this out. So the impulse will equal the final momentum, which will be 0. I'm writing that for the final momentum, minus the initial momentum, which will be the mass of the ball, times the initial velocity. Okay, so again, I'll write this all out again. 0 minus the mass, which is 0.35 kilograms, multiplied by the initial velocity, which was 14.7 meters per second. So using my calculator, I'll put in 0.35 times 14.7, and I need two significant figures. So I'm going to round this down to 5.1. So 0 minus 5.1, that's just going to be negative 5.1 Newton seconds. This is the impulse and the change in momentum. Because impulse and change in momentum are equal to each other, as we see right here. So we found the change in momentum. That is the impulse, negative 5.1 Newton seconds. Okay, so part B, determine the amount of force exerted on the ball by Leah. To find the amount of force, we're going to use this first expression, impulse is equal to force times time. So now we can go back to the original word problem at the top there and look at the time and use that information to find our impulse. I'm sorry, to find our force. We're looking for the amount of force exerted on the ball. So we can put in a number now for impulse. We just found was negative 5.1 Newton seconds. And we'll be multiplying the force by 0.33 seconds. And I'm getting that from up here. That's how long it took to bring the ball to rest in the net. It's not an immediate catch. There's like some delay, some gradual slowing down. All right, so now we're going to use some algebra to solve for the force. Right now, force is being multiplied by 0.33, so we're going to divide by 0.33 seconds to undo that. We're going to do that to the other side as well to keep it equal. And that goes away. The units over here, Newton times seconds divided by seconds, the seconds cancel each other out. So we're left with newtons, and then we'll put this in our calculator, 5.1 divided by 0.33, and we get a big long repeating decimal. We don't need all those digits, we only need 2. So the first 2 digits are 15, and we'll round down. So 15, negative 15 newtons is the force. All right, so that's all I've got for you in this video. Remember, a bad attitude is like a flat tire. You won't get anywhere until you change it.